What is HDL?
The high density lipid.
Yeah, HDL, high density lipid. Yes, high density lipids, not proteins, so high density lipids. So LDL,
Low density lipids.
low density lipids. So which one is more unsaturated? So which one is saturated? Which one is unsaturated? High density lipid is saturated or low density lipid saturated? That's what I was right at that time. So low density is the one which is saturated. Why it is low density, I tell you in a minute. So see, low density is not saturated. All right. So the branches they have, well, if they have not saturated, so then it has more branches, right? So like this.
Like
Okay. So what happened if you got a lot of branches like that? All the carbon saturated. See? See, they actually, these alkyl groups has a lot of branches. The number of branches wise, it is more if it is fully saturated. So then what happened when they spread out? So because this is one R group and there's another one here. See, CH3 group. This is the main backbone of the molecule, and these are the side branches. So these branches repels each other. This is R group, this is another R group. These R groups pushing each other. All right. So pushing each other, spread out. Pushing each other, spread out. So therefore, you cannot pack them easily. So like they would be like this, right? So in nature, it will be like that, right? So it's a lot of spreading. So when they're spreading out, so the density is packing, right? So the packing quality going down. So they become more spread and become less dense. That is why you call low density. All right. But in contrast, if you have more of these things, right? So more of these things, right? And 6 of them together. 1, 2, 3, OH here, or maybe another CH2. CH3. So if the other one is same side, we call cis. If the other one is other side, we call trans. Right. So when this happened, it's reduced the density. So 6 times repeat of that. 6 times of that. Right? See? 6 times. So omega 6 happening in starting from here now. 1, 2, 3, and this is carbon 6. Carbon 6. So that is why omega 6. All right. To find what is the omega value, you have to spread out the structure. So we talk about that again later. So omega 3 mean the third carbon is the one having the double bond. But having said that, the first double bond, for after that, you can have, so starting from COOH, because fatty acid has COOH, yeah, CO, fatty acid. So this is the first carbon, starting from that one. Got it? So now it is already, I think, clear for you. So we discussed last week as well. So the low density is the unsaturated one. So unsaturated one is high density. Okay.
Yeah.
The temperature wise, so which one is liquid at higher temperature, and which one is liquid at lower temperature?
Okay, so like the one that's like liquid at high temperatures, so it would be like the one with a higher boiling point, right?
Yeah, put like that. We take oil and butter. Okay. So in the room temperature, you have oil, right? So I just draw the thermometer. So this is, don't mix that, please. So the room temperature is, say, Fahrenheit 37, or for centigrade 25. 25 degrees Celsius. So you have a liquid, the bottle of oil. The bottle of oil, right? Liquid. Like a canola oil, right? Olive oil. So they are liquid. So meaning that their temperature, their boiling point is low. Your melting point and boiling points are low, right? Low. Melting points. That is why it is room temperature. It is a liquid. Yeah. So what about things room temperature which are solid? Yeah. So
they have a high melting point.
Yeah, they have high melting point. So you take example, some butter, room temperature you can keep 25 degrees Celsius, nothing happened. It is butter. It's a chunk. So supermarket butter, 25 degrees, maybe not melting. So certain other the oils like so the oily stuff which is like a jelly-like thing, which is not liquid at the room temperature, right? So they are the one high melting point. Okay, so they are fully saturated. So that is the difference. So the high melting points in saturated fats, low melting points in unsaturated fat. So this is saturated. Saturated fat. So anything liquid in room temperature, more unsaturation, right? So remember the oil. the canola oil, right? We know that. The olive oil, we know that. So they are room temperature liquid, right? So then they have low melting points. All right.
Yeah.
So because of the situation, like when you have a lot of leaks, so they have hydrogen bonds. So they have some links have oxygen and nitrogen. So they can have nitrogen or oxygen or anything. So then they can have a lot of hydrogen bonds, right? Hydrogen bonds or different polar dipolar bonds in between these side chains. So that's how they're getting their melting points high, right? So
Yeah.
so make it correct. So make it correct. Then we can go to the question. All good?
Yeah.
Done.
Yes.
Okay. Now this. So we are dealing with your paper, right? So this paper, if you want to look at, this is 2018, right? So this question, organic compound have the numerous and diverse due to the nature of the carbon atom. The international convention for naming and representation of the organic compounds. So draw the structural formula of 2-methyl propane 2-ol. Yeah, could you? Pretty sure you can draw it.
Yeah.
That is excellent. No, that's fine. 2-methyl propane 2-ol. That's excellent. So now cut and paste that. Now remember that is structural formula.